Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, my dear student Prep 1? Let's today to explain the second lesson, chemical compounds. You have learned in the previous lesson about different type of elements like metals, non-metals, and noble gases, and also different type of bonds like ionic bonds and covalent bonds. Today we are going to explain the chemical compounds. The first point in this lesson, the valency. What is the valency of any element? Valency is the number of electrons that an atom gains, loses, or even shares during a chemical reaction. Okay? Number of electron gains or loses or even shares by the atom during the chemical reaction. For example, oxygen 8, the electronic configuration of oxygen 2, 6. So oxygen can gain 2 electrons during the chemical reaction or share with 2 electrons during the chemical reaction. So the valency of oxygen is 2. Why? Give reason for the valency of oxygen is 2, or oxygen is a divalent element because it can gain 2 electrons during the chemical reaction or can share with 2 electrons the chemical reaction. Another example, Cl17, the electronic configuration of Cl287. So Cl can gain 1 electron during the chemical reaction or can share with 1 electron during the chemical reaction. So it is a monovalent element. Okay, and the previous elements, metals or non-metals, its valency can be determined from the electronic configuration. Look at the following table. Here are some elements and their valence electrons. For example, lithium and potassium and sodium is monovalent. Calcium and magnesium divalent. Aluminum trivalent. Zinc divalent. And we have some elements that have different valences, like iron have 2 and 3, or divalent and trivalent. But the name of the iron is changed from divalent to trivalent. In case of divalent, iron is ferrous, and in case of trivalent, iron is ferric. Okay, and we also have sulfur have 2 and 4 and 6 valency, or divalent, tetravalent, and hexavalent. You must keep these valences of these elements, okay, and study them hard. Another point in our lesson, the atomic group. Atomic group is defined as it's a set of atoms joined together and have the behavior of one atom during a chemical reaction, having its own valency, and it is not existed lonely. Okay, it's a set of atoms joined together, have the behavior of one atom during the chemical reaction, and have its own valency. The table represents some of atomic groups. You must keep these atomic groups. Hydroxide OH, its valency 1 or monovalent. Nitrate NO3 monovalent. Bicarbonate HCO3 monovalent. Ammonium NH4 monovalent. Nitrite NO2 monovalent. Sulfate SO4 divalent. Carbonate CO3 divalent phosphate BO4 trivalent. Why we must keep this atomic group? Because it will help us in writing the chemical formula of a chemical compound. We can express a molecule of a compound by a certain formula, and this formula is known as a chemical formula. Okay, so the chemical formula is very important to know the elements of the compounds and the atoms of it. For example, the chemical formula of water is H2O, which means that water molecules composed of 3 atoms of 2 elements. We have 3 atoms, 2 hydrogen and 1 oxygen. Okay, 2 hydrogen and only 2 oxygen. So the chemical formula, it's very important to know the elements and the atom of these elements. Exercise. Study the following table that indicates some compounds and their chemical formula. Notice the way of writing each formula, then complete the missing parts. Compound 1, sodium carbonate. Sodium carbonate, its chemical formula Na2CO3. And the number of atoms in the molecule, we have 3 oxygen and 1 carbon and 2 sodium. So the number of atoms here is 6. And the number of forming of elements, we have 3 elements: oxygen, carbon and sodium. So 3. For copper carbonate, CuCO3, we have 3 oxygen and 1 carbon and 1 copper. So we have 5 atoms. And the number of elements, we have oxygen, carbon and copper. So 3 elements. And so on. So how we can write a chemical formula of any compound? To write the chemical formula, we have steps. Step number 1, write the name of the compound in words. Okay? Write the name of the compound in words. Number 2, write the symbol of each element or atomic group down to the name. 3, write the valency down to each symbol. Number 4, all numbers are to be shortened as much as you can. تمام، يعني اختصر الأرقام. And 1 is not written. For example, how we can write the chemical formula of sodium carbonate? First, write the name of the compound in words. زي كده كتبنا sodium carbonate. In words, sodium carbonate. Step number 2, the symbol of this element or group, NaCO3. Then number 3, write the valency of these elements. 1, the valency of sodium, and 2, the valency of carbonate group. Then exchange these valency. هنبدل الvalency 2 and here 1, but 1 is not written. ما بنكتبش ال1. تمام. بعد كده بننزل بالسيمبل يبقى Na2CO3. So the symbol of sodium or the chemical formula of sodium carbonate is Na2CO3. Try to answer the following exercise in your homework. notebook and send me in our WhatsApp group. Ask if you need help. The third point, and listen to type of compounds. Compounds or chemical compounds are classified according to their properties into acids, bases, salts, and oxides. Acids, bases, salts, and oxides. For example, number one, acids like HCl, hydrochloric acid, and bases NaOH, sodium hydroxide. So what is the definition of acids and base? Acids are materials that dissociate in water, producing positive ions of hydrogen H positive. Again, acids are materials that dissociate in water, producing positive ions of hydrogen H positive. And acids are common in some of their properties. Or what are the properties of acids? Number one, it has sour taste and changing the color of litmus paper to be red due to the presence of hydrogen ion. Give reason for acids turns the litmus paper to red. Why? Due to the presence of hydrogen ion. And the chemical formula of mineral acids begin with hydrogen joined with one of negative atomic group such as sulfuric acid, nitric acid, and also hydrogen may join with some nonmetals like chlorine or bromine, like HCl and HBr. The second type of chemical compounds, bases. They are compounds that produce a negative hydroxide ion when decomposed in water. Again, they are compounds that produce negative hydroxide ion when decomposed in water. And what are the properties of bases? Bases have a bitter taste and feel slippery, and they can change the color of litmus into blue due to the presence of hydroxide ion. Again, it have a bitter taste and they feel slippery, and they can change the color of litmus into blue due to the presence of hydroxide ion. For example, NaOH, KOH, CaOH by 2. The third type of chemical compounds, oxides. And oxides, an element joins with oxygen producing either oxides of metal or non-metals. So we have two types of oxides, metal oxides and non-metal oxides. Metal oxides like sodium oxide and aluminum oxide, and non-metal oxide like carbon dioxide and sulfur trioxide. Number 4, salts. Salts are produced as a result of chemical combination of positive metal ion or positive atomic group with a negative atomic group or negative ion. For example, NaCl. Na is a positive metal ion and Cl is a negative ion. Okay, so here we have a positive metal ion with a negative metal ion, NaCl, sodium chloride. Examples, table salt and anhydrous copper sulfate and sodium nitrate. Again, examples of salts, table salt, anhydrous copper sulfate and sodium nitrate. And the following table represents the salts that can dissolve in water and salts don't dissolve in water. Sodium chloride, potassium sulfate, calcium nitrate, sodium sulfide, these are salts that can dissolve in water. But silver chloride, lead iodide, and lead sulfate are examples of salts don't dissolve in water. Okay, let's to show the summary of our lesson: valency, atomic group, chemical formula, types of compounds,